Hey all, good morning, good afternoon, and good evening. I hope I am audible and clear, and you can see my screen clearly, right? So, coming to our course, Power BI and PostgreSQL, right? And the certification we are going to target is Microsoft BI, Business Intelligence Tool Data Analyst, PL 300 certified, right? Now, before going to the topics, right, let us understand why we are learning this course and what this course is going to give us uh, the insights, right? If you see the course structure, we have data warehousing, PostgreSQL, and Power BI. This is the order we are going to cover, right? And in this course, Power BI is going to be the major subject. Data warehousing and PostgreSQL are like a foundational, or you can say they are like a bridge, right? Knowledge bridge, and overall within the 3 weeks course, we are going to have one class for data warehousing and 4 class for Postgres, and rest all thing would be covered for Power BI, right? Now, why to learn all these things in parallel? Now, I have a simple diagram. If you see this one, data to insights journey, right? When you say data, what it mean by data? Anyone has an understanding? When you heard about data, what comes in your mind? So guys, I want to make sure we are having more interactive class, right? So kindly request you to respond to my queries, either yes, no, or whatever you know about the question, right? So my simple question is, what comes in your mind when you heard about the word data? You can post it in the chat channel. So I'm waiting. I'm just watching the chat channel to get a response from all of you. So what comes in your mind when you heard about the word data? Information, okay, right? Now let me put it in this way. So all the activities that happens as a part of the business, right? If it is a banking sector, the all the transactions or opening accounts, loan account, personal account, saving account, all these are activities. Now, capturing all these activities, we call it as a data, right? Say account is open. Information related to this account opening, we call it as a data, right? Today, 1,000 transactions happen, and you have all the details related to those 1,000 transactions, right? Suppose someone comes and he wants some information about his transaction, that is going to be the information also, right? At the end of the month, if you want to know how many transactions you have done, right? What is the total expenses? What is the total income? To calculate all these things, you need all the individual activities or individual data elements, right? Now, as we know, everything is moving to digital. Now, earlier small shops used to have manual entries. They do everything in the manually by putting a book and pen, right? Now, if you see, go to the small coffee shop also, right? They are keeping a small computer or laptop and making sure things are captured there. And they would be having a software provided by one of the IT company. And these IT companies provide service to them to maintain their accounting system, right? So over the period of time, we are having huge amounts of data is being available, right? So which means there would be lot of technical people, software analysts, software associates, or software engineers are needed to maintain the data smoothly without any service interruptions, right? So that is called data factory. Now, at one point of time, organizations think that maintaining this data is kind of a uh, expensive thing, or they feel it's a kind of a uh, what we call it, I'm not getting the terminology. Simple. There's a one word is there. I want to spell. I mean, it's a kind of a additional cost to company, right? Because there would be regulatories, there would be say government regulatories. Okay, you need to make sure all your business related data that you need to maintain for 6 years, for 5 years. If a customer comes and asks you about his account details, that you should be able to provide him. Especially in banks, we have a strong regulatories, right? If a customer comes and asks you that I want my information, you should be able to provide the information after 5 years also. Similarly, if a customer says, okay, you should not be storing my information, right? Please kindly clear all my information. Then we as an organization should have required technology to find out where the information is stored about particular customer and remove all those things, right? So to maintain all these things, we have a data factory. In Microsoft, we have Azure Data Factory. Teradata, they provide Teradata. Similarly, there are a lot of companies, Oracle, PostgreSQL, they are providing databases, Hadoop systems, all those things, right? Now, over the period of time, right, it is realized that we can use this data as an asset, right? Maintaining this much amount of data is not going to be liability for us. We are going to make this asset if we are able to make them visualize, right? Then we got a lot of visualization tools. Earlier, we used to call them as a reporting tools, data stage, right? There are some within Microsoft, we have SSI like that. And now we have Power BI, Tableau are the market leaders, right? So what this Power BI and Tableau are going to do is they are going to visualize the data and give us the insights about our business, right? How our business is trending over a period of last 2 months, last 6 months, last 1 year, right? Is our business going upward, downward? All these things we can analyze with the help of Power BI, Power Business Intelligence tools, right? So I want to just give you this journey. Now, why Hari has added data warehousing and database, right? Because if you see, the success of Power BI depends upon the quality of data we maintain in our organization. And the more we understand about our data, then we can do our job more faster. That is the reason, right? We should be having a good understanding about at least one database, right? Especially when you say database, it is going to be the language that is used to interact with the database is SQL, structured query language. So we are going to learn SQL with the help of PostgreSQL. Now I'm going to give a detailed understanding why we are using PostgreSQL, right? Along with, we are also learning data warehouse. Now, when you say data warehouse, I want to just remember you about the Newton's laws, right? We all, I hope we all know Newton laws, right? They are almost invented in around 18th or 19th century, right? But still we follow them. Similarly, whatever the new technologies, whether it's a machine learning, artificial intelligence that we are going to use in our Power BI, but the underlying theme, getting the data, cleaning it, transforming it, storing it in the databases, these things are not going to be changed. So we are going to learn basic fundamentals within the data warehousing. Okay. Now, to achieve this particular flow, data to insight journey, in this journey, we have different tools are there. Not one tool is going to serve our things. We have different tools. Now, if I want to show you, if you see here, for operational data, right? We have day-to-day things. So we have SQL databases, we have Cosmos DB database. These are all different databases, right? We can have different databases, and also to get a real time, we have Event Hub tools. And all this data, we are going to take a copy into data injection or ETL, extract, transform, load. And here, if you are going to use a Microsoft tool, then we have Azure Data Factory. If you want to use AWS, then you have DynamoDB. AWS provided inbuilt databases, and AWS provides service Azure Streaming Analytics, right? And once data got ingested, we have Databricks, Azure Data Lake, and all these things are there for your analytical data processing. And finally, we have a visualization and data modeling tools, right? And let me close it. And here we are going to use Microsoft Power BI, right? And many of the students have doubt. Hey, there are a lot of names are coming in the market. Do I need to learn everything? As my honest suggestion is, no need to learn in depth everything, but pick up one tool, learn in depth about it, and also have a understanding about other tools, right? Because when we are using Microsoft Power BI, it is important, right? Which particular tool is giving us the data, right? What is its mechanism? So at a high level, we need to know all those things. So that is the reason we are learning PostgreSQL, right? And also the reason for I'm taking PostgreSQL, it's a open source, completely free. So when I say when I can pick one of the database from Microsoft Office, Microsoft Azure side, but what I feel is that since you are learning a Microsoft Power BI tool, so let us have a exposure to one of the open source database also. Right? It's a combination, deadly combination, which I feel. So instead of just sticking to only Microsoft tools, let us have one Microsoft tool that we are going to work on Microsoft Power BI and also learn details from the database, learn database from an open source tool, right? So this is what we are going to cover, Microsoft Power BI. So within the Power BI or our thing, these are all the topics we are going to cover, data warehousing concepts. And we are also going to learn installation of the PostgreSQL and how to work on DDL, DML. When you say DDL, the full form is data definition language. So the SQL query that we are going to write to create the tables, to create the views, that is called DDL. Similarly, once tables are created, we need to insert the data or retrieve the data, right? So, or modify the data. So those things we call data manipulation language, right? We are going to do a good hands-on with the SQL query, structured query language. Now, what is this SQL? It's a universal language that helps to interact with the databases. Like how English is the universal language, right? If you learn English, we can manage to live in any majority of the countries in the world, correct? Similarly, here our concept is to learn SQL as much as possible so that in case if you are supposed to work in any other database, then you can easily start managing working on it, right? We have tools also there. We don't need to write any SQL, just we can do some drag and drop, things will commit. But our focus with respect to PostgreSQL is to learn structured query language. Okay. Followed by, we are going to learn more about data types. This is one of the important thing to understand how data structures are created. Okay. And followed by Power BI installation, Power Query, Power Pivot, visualization, and publishing, right? So these are all the things. Mainly we are going to see from Power BI desktop, right? We are going to learn. or see different source systems, how to connect and pull the data from different systems. Right? I'm just opening one of the Power BI report that we created. Right? So if you see here in the get data, or you can see these options, data, right? We are going to touch base around getting the data from files, from database, from websites, anything. If you see, Power BI has the capability to connect almost hundreds of systems. You give us a name, we have the option to get the data and pull it. And if I go further category wise files, Excel, text, XML, JSON folder, databases. Majority of the databases are covered across the platforms. Microsoft related tools, data flows, thematic, power platforms, right? So our main focus would be with the Microsoft desktop, Power BI, Microsoft Power BI desktop, where we are going to do hands-on with all these visualizations. These are all the visualizations we have created, right? And we are also going to see Power BI services, right? And we are having good number of sample reports that helps us to learn the things. Revenues, artificial intelligence, corporate spend. We are going to see all these things. And I'm going to create you an account in the Microsoft Power BI where you can practice the things. All I need your support is to do lot of practice. That's it. I would be there to support you. Okay. And we can do some slicing and dicing with rest with the Power BI dashboards. Right? If you see here, suppose I want a functional, you can see. These are all like interactive things. Suppose if you want to interested in North America, right? So this is about the Power BI. And every class we are going to have 1 hour class, right? And we are going to start the class 15 minutes earlier for to take the queries, doubts, anything from the students. And mostly we would be having 15 minutes more, right? So consider daily 1.5 hour for the class in the same time, and also another 1 hour for your practice. Okay, so practice is very, very important, right? Without doing the practice, it is hard to learn the things. So I would request you to dedicate coming 3 weeks at least 2.5 hours, 1.5 hour with me and another 1 hour with the practice, right? All our class recordings, classes would be recorded and they would be available in the YouTube link. So, which means that it is very easy for you to watch them anywhere and practice the things. You don't need to be worried that, okay, I need to have a laptop. I mean, you can, whenever you want to review the classes, you can just watch the recordings and then start practicing the things, right? And to be honest, you would be having a lot of doubts when you started initially, right? So when you are doing a practice on the same day or subsequent day, it would be easy. We can close the things, right? Or else things will get backlog, more things would be backlog, and it is hard for you also to again understand the things. But the another interesting thing is, if you see this Power BI being a Microsoft tool, right? It almost similar to the Microsoft Office like Excel, PowerPoint, or MS Word, right? If you see in Microsoft Excel, you have charts, right? Like maps chart, pivot chart, tree map, line chart, everything is there, right? Similarly, in the Microsoft Power BI, see you have the visualizations like bars, line charts, maps. everything. I mean, we can say that Power BI is like an artificial intelligence tool or advanced tool beyond Microsoft Office like Excel, PowerPoint, and everything, right? And currently, the market leaders are Power BI and Tableau. Now, Tableau, the user interface and the way it works is completely different. So, for beginners, Microsoft Power BI is the best startup. And when it comes to the course, we are starting from very fundamentals and we go to the intermediate level that is required to complete the certification and get a job, right? Any questions till now about the course structure, timings, and how the way we go on? You can post over the channel. Vanessa, do you have any questions? Okay, I will take it as no. And once the course, I mean, in parallel to the course, when we are going, we would be focusing on the certification. Okay, so as I told you, right, we would be covering Microsoft Power BI Data Analyst Associate, right? And if you see, this is the intermediate level, and the role is going to get data analytics, right? And we need to renew this certificate every 12 months, and it is free of cost for renewal. Okay, and they would be putting a test again to make sure, yes, we are good in the subject and we didn't miss anything, right? And these are all the topics like 1 hour, 4 hours, 5 hours. These need to be completed as a part of our course, right? We would be completing 70% of these topics, right? And as a revision, I would be asking all the students to one more time just go through all these things, right? And after that, we would be having practice assessments. Can take any number of times practice assessment. And if we are scoring continuously above 80, then it is good time to apply for the certification, right? And if you see the certification costs around $165, right? You can go with your local currency and we can pay and exam. And we have a dedicated team to assist you in the examination in case if you required any support, right? Or else I would also be available. On the first, I'm the first point of contact. I would be available, making sure that we have covered all the topics and ready for the exam. Okay. And in case further any support is needed in the certification, we would be having a dedicated team. They would be helping you. Okay. And at the same time, we can also we are also providing the interview guidance, like LinkedIn profile preparation, right? And applying jobs on behalf of you. So those are all separate things. But definitely, what I want to say is, as a agile hands-on coaching, we are making sure the end-to-end support is provided for the students, right? Any questions or queries? And there are huge opportunities are there. If I put Power BI jobs in US, see, 28,000 plus jobs are there, right? And we are going to tailored out these things based on the US, right? 12,000 jobs we have. And if I take entry associate, just taking the mid level, see, we have 3,700 jobs are there, right? So opportunities wise, yes, we have good opportunities in the Power BI tool, right? We all know there is in US there is a market turmoil or market fluctuations is there, but definitely let us see in the long run, right? Because it is common in the market, like going up and down. Yeah, here it is, entry level positions. I selected both entry level and associate. If you want to see only entry level, 2000 jobs are there, right? And each individual is different. That's what I believe, right? So once we course is completed, I connect with you one to one and try to self assess and decide, okay, what should be the level of experience that you are good to put, and accordingly we will train the people, right? Because some people are good enough that they are ready to go at the mid level also, but some people it's good that we start from the entry level and slowly they climb up the ladder, right? Any queries or questions? So I will give a pause here. Hey all, once again, good morning, good afternoon, and good evening, right? So I hope you got a decent understanding about our course and how we are going to take it forward, right? Now, as a part of our first class today, we are going to cover data warehousing concepts, right? So these are like Newton laws, like how Newton laws is important for physics, for all the data related projects. If you use artificial intelligence, machine learning, analytics, whatever you feel, but the underlying concepts, data warehousing concepts, are not going to change anywhere. And if I wake up you at the midnight and ask you a question about these things, that you should be good enough to answer them without any doubt, right? If we are coming at to that level, then we won't have any doubts, okay, why we are using these tools, okay, why we are arranging these tables in this way. All those answers would be clarified, right? Now, as I said that image talks about, I mean, one image is equal to 1000 words. So to explain this one, let me first take a simple image, right? This is the one which I use, and this is perfectly fit for the doubts and clarifications. Oh, sorry, right? If you see the below between one is warehouse. Now let us start from left to right. Hmm? Now, just now we discussed it, right? There is a lot of activities being happens in the business world. If you go to the Walmart or if you go to any of the coffee shop, right? All the customers come and they order something, and the persons at the counter, they take the orders and they deliver it, right? And in the back office or in the kitchen, right, you would be having inventory or warehouse where you would be storing lot of material those are required to prepare the coffee or whatever it may be, whatever the order they have placed, correct? Now to capture all these activities, we are having computers and laptops, right? So these day-to-day activities, all those things, we call it as a operational systems, right? Because you have an organization and it is operational, right? And you are capturing all the activities, observations, everything in the databases, right? So if you take a bank or anything, whatever the day-to-day transactions in the bank, we call it as a transactions. If it is a Walmart or something, then we call it as a sales, right? So what happened on daily basis? All these data or information is captured in the operational systems, and it can be a Teradata, it can be a Oracle, or it can be Azure Data Factory also, right? And we discuss it, right? As per the regulatories organization that we need to store all this information for a period of time. Now, what happen is if you daily going storing this data in single system, right? Your space would be increasing or your size of your database go beyond. And at one point in time, it would be hard to maintain the systems also, right? And at the same time, if you want to analyze those things, okay, how my business is going on, right? And parallelly, when you are doing some analytical things on the same database, so there may be high chances that our systems will go having run into the performance issues, right? So what it is decided is the two great scientists, they come and they said that okay, let us build a warehouse. Now when you say the warehouse, we all know, right? In each and every factories, industries, they maintain a warehouse. And what is the purpose of that warehouse? To maintain their stocks, right? To maintain the raw material, or at the same time to maintain the finished goods. So what is the benefit they are going to get? Suppose if the raw material prices are fluctuating, right? So good thing is when we purchase this raw material when the cost is low, then we can get maximum profits, right? Okay, today the material cost is low. I purchased it, but where I can keep it? In the warehouse. Correct? Similarly, we have production lines are running at a high speed and lot of products are created, but the market conditions are not good. So we store them in the warehouse so that when market conditions are good, then we release the finished products into the market. Similarly, the warehouse is going to be acts as a place, right, where I can take a copy from the operational systems and keep it here. And whenever I need them, I'm going to use this warehouse, right? Considering this is a data warehouse, so we are calling it as a data warehouse, simple. So in this warehouse, you are storing the data and this warehouse is going to be used for data storing. So we are calling it as data warehouse. Now, physical warehouse, yes, you will build a big shop or something and you store them. But for data storing, so we have the software companies like Oracle, Microsoft, Google, and they're providing the database services, right? So these databases helps us to store the data in a structured format, correct? Now, the databases or files, those are used to store the operational data, right? All the operational data, we call them as online transactional processing systems. We also call as OLTPs, right? Now, what I decide is at the end of the day, okay, today business is closed, right? What I am going to take is I am going to take a copy of all the new records are added or the records those got updates, right? So on the first day, or we call it as day zero, when you start your systems, you would be having 100 records. So all the 100 records copy would be taken after the business hours so that we don't impact the online transactions, right? And this data is stored in the warehouse. Now, if you see how it is being stored as a summarized data, right? Suppose today we have 100 transactions. All these 100 transactions are stored as it is as a raw data. We call them as a long-term data stores, right? At the same time, we are going to store them in a summarized, like what is the total sales of the day? What are the total sales for the computers? What are the total sales for the laptop? So summarized data. And we also store metadata. So metadata means information about what kind of data you are storing. Okay. Say I am storing customer related personal information, his name, address, date of birth. So that kind of information is stored in the metadata. So if a regulator is come and ask, hey, let us know what kind of information you are taking from the customers and where you are storing it. Then this metadata database is going to help us to tell what kind of data we are storing, right? So now warehouse is going to help us to take a copy and maintain raw data, summarize the data and metadata, right? Now in future, if I got a new requirements, okay, I can refer to this raw data, which is going to have complete history, right? And I can create a new report. In this way, data warehouse is going to help us to maintain the data consistency accurately and the historical, right? And another thing is this data warehouse also helps us to split the analytical thinking or analytical process from the operational process, making sure both the systems work parallelly faster, right? We all know, right? So if you have something, say if you have a tank and if it is getting full and if you feel that you need more capacity, then we will add one other uh, further more capacity, right? Similarly, the existing systems are running out of resources, so better some process move to the different system, right? It's like catering the additional work to the new system that we call as data warehousing. Now, considering this data warehouse is going to be used for analytical purpose, I'm going to call it as online analytical processing systems. We also call OLAP, right? So our journey starts here, understands how data is stored and how we are going to use it, right? Now, once we have created a data warehouse, right, we can create a data marts. Data marts are also data warehouse only, but they are a kind of subset. Say I have created a data warehouse at organization level, right? Centrally. Now we can go with the purchasing department that they really don't need to access entire organization data, right? Even we have a restriction that a particular department are supposed to have data visibility to some level. Suppose if you take the HR department, HR department can have the access to the employee salaries, their insurance benefits and everything, right? But if you go to the marketing department, they just need to have access to the employee name and phone number and more than email address. Beyond that, they are not supposed to access because salaries and everything, health information are sensitive, right? So then what I'm going to do, instead of creating one more data warehouse, I just take a copy for purchasing department, for sales department, right? So a data mart is a subset of data warehouse and it is going to have the same properties, features and everything like data warehouse. So on this data mart, we do the analytics, reporting or mining with the help of our Power BI, right? Is it clear till now? End-to-end flow of data warehousing, how it looks. Let me save this file. I will be sharing with you. And another important point is all the databases, right? Whenever you want to represent the database, we are going to use this cylindrical symbol, this one, right? And what I feel is that if I want to just correlate this to our day-to-day life, right? A database is like a house, okay? So within the database, we are going to have different tables and they are related, they are relational tables. So this is the table, right? So like within the house, we would be having different rooms, right? Why we are keeping different rooms? For us to easily manage our life. If you have single room like warehouse and if you are keeping everything at one place, it is hard for us to retrieve. Correct? So we would be having living room, bedroom, kitchen. Similarly, we would be having different tables. Use it to store like accounts details, customer details, branch details, transactions. So all these things. So like how we effectively manage. And there would be a connection between these rooms, right? Similarly, these tables are connected with the help of primary and foreign key relations. That is the reason we call a database as a relational database management system, or DBMS. Okay, so this is a basic fundamental, and I want you to correlate this to our day-to-day life so that you would be very easily understanding, right? Any questions till now? I want to make sure you should not be having any doubts with respect to the fundamentals, because fundamentals are very important for the success of our career, not only here, in any field. We should be strong enough to know fundamentals. Vanessa, any queries or questions? Roland, Kinsley, Isha? Okay. So now let me take the topic of Ralph Kimball and Inmon. Thank you. So we have two great scientists, W.H. Inmon and Ralph Kimball, right? So they are the one who has proposed this data warehousing, right? Like Newton has proposed three laws and he has kept his name. Similarly, Inmon and Kimball, they have proposed two different theories and they have kept the names, right? Now let us see what they have proposed. Okay, before going this one, let me show you some theoretical part about the data warehouse. Right? A data warehouse is a central repository of information that can be analyzed to make informed decisions. Right? When we say informed decisions, right, the management is going to take the decisions based on the facts, not on assumptions. And data warehouse is going to help to put the facts in front of in the table and take the right. And data flows into data warehouse from transactional systems, relational databases, and other sources, right? This is what we have seen. Transactional systems, flat files, and we have different things where it will be doing, correct? And guys, I'm going to share this article with you, right? And the learning material that I'm going to share, those are all handpicked. And I want you to go through them thoroughly and be comfortable with you. Typically on regular candidate, business analyst, you are going to be data engineers, scientists, and decision makers access through BI tools, SQL kinds, and other tools, right? And if you see the architecture wise, a data warehouse architecture is made of up of tiers. The top tier is the front end client that represent results through reporting, right? We are sitting on the top, the top tier. Front end client that represents the results through reporting, analysis, and data mining tools. This one, analytics, reporting, analytics, and all those things. The middle tier consists of analytical engine that is used to access and analyze the data. The middle tier, right? And the bottom tier of the architecture is the database servers where data is loaded and stored, right? That's what here, all the databases. Data that is accessed frequently is stored very fast, and you have different things that can be stored, right? And what are the benefits? Informed decisions, consolidated data from many sources, right? Since we are going to pull or get all the data, right? And we also call a data warehouse as enterprise data warehouse when we are getting all the data at one place, a single system right? And that is going to be a part of one place. Historical data analysis. Yes, we are going to maintain historical data. Data quality, consistency, and accuracy. This is what we are going to have. Quality, consistency, and accuracy. Separation from analytical processing from transactional process. Separation of analytical processing from transactional database, which improves performance of both the systems, right? So these are all the key points, right? We have touch based, right? We are separating the analytical processing from the transactional so that both can work faster, correct? So this is all about data warehousing. Similarly, we have databases, data lakes, right? So whenever you are storing some semi-structured or unstructured data, then we come up with the data lakes, right? Now, when it comes to the Ralph Kimball and Inmon, they are the two great scientists, right? And what they said, let us see what Kimball has suggested. Now, what Kimball is saying is, right, don't create a data mart first, right? You have different data sources, right? You have data coming from HR system. Similarly, you are getting the data from marketing system, right? And you have a manufacturing plant is there, production systems are there, right? Now, what they are saying is create their own data mart, right? And then once you got the data marts are created, then integrate them into a single data warehouse, right? This is like a, if you see the Scrum methodologies, right? What they say, break the things into achievable business outcomes, right? Deliver them and get the feedback from them, and let's go on incremental, right? So this is a incremental one, right? And Kimball suggested get a clear and on the top of the data warehouse, now create the reporting layer. That is what Kimball's suggestions, right? And when you see the benefits of Kimball, yes, set up and build her quickly because we would be starting with one department so that I can connect easily with a single department and do all my groundwork and start building the data mart for them, right? Generating report against multiple schema is very successful since we have multiple. Data operations are very effective, occupies less space in the database, and management is easy. That's what they say. Now, what Inmon says, right? Now, what Inmon says is that no, don't create multiple data marts first. Just get all the source systems. Suppose if you have a new business line added, get that data to the data warehouse centrally so that I can have a single view by sitting at the head office, right? Having access to these data warehouses. Yes, I can analyze data, right? And then I can create a copies to individual business lines so that reporting can be done with the respect to business lines. That is what Inmon suggests, right? Now, Inmon is like a big bang. Get all the teams, all the departments at one place, understand how they are correlated, how business functions interact between each other, and get the central data warehouse built, right? We call it as an enterprise data warehouse, and then start reporting. So, what do you think that one is? Which one is good? Is a Ralph one Inmon is better or Ralph Kimball model? I mean, if you think of it, if you have a business, which model you want to suggest? Any suggestions? Right? Yes, you are right. Right. So both of them are good. That is the reason today we are learning them. Let us see a comparative analysis of both of them. Right? Because some organizations which they want a single place for their entire systems and to avoid duplication or repeated work, then they will go to the Inmon. Right? Uh, Guys, we would be having another 20 more minutes, okay? Not more than that, but we are going in a slow phase. to cover the topics, right? Now, the approach for Kimball is it's a bottom-up approach, right? We would be starting with each and every individual business lines, and then we will go to the top level. And Inmon is top-down approach, right? We build the things from the enterprise level, and then we will give a copy for each and every business department. Data integration, individual business areas, right? We sit with each and every business line, and we will start building this one. It focuses on enterprise-wide areas, right? Because whenever we want to build an enterprise data warehouse, we need to correlate how each and every department are interrelated. Build time, it is efficient and takes less time, obviously, because we are starting with small pieces, so we can quickly complete the things. It is complex and consumes a lot of time, right? Will you agree with me? Inmon is going to be complex because we need to get all the departments at one place and draw the lines, how they are interconnected. Accordingly, we should be creating the tables and database. It says a iterative steps and cost effective. Initial cost is huge, the development cost is low, right? So initial planning, definitely we would be having huge cost, how to plan it, but further development cost is going to be low. Skills required. It should does not require such a skill, but a generic team will do the job, right? As we said, right, each and every department. So if you pull the department level experts, yes, we can do the things. Whereas in Inmon, yes, we need a specialized people who can understand the relation between the departments and draw the business diagram. Here maintenance is difficult. Here maintenance is easy, right? This is the first thing, right? That is good. The reason is because we are here, we are having all the systems at one place, right? So that means we can avoid some redundancy, duplication, and all those things. So that is the reason maintenance is easy for Inmon. That is the reason some organizations will invest more initially, right? So that they can reduce their operational cost, right? Fine. Data model. This is very important thing, right? It prefers data to be in the denormalized model. It prefers data to be normalized model, right? Now, I hope these normalized and denormalized are the new words you are hearing. To give you a detailed understanding what it mean by normalized and denormalized, let me show you some tables here. I have created some data to explain this one. Let me open that one. Okay. We also call this as normalization and denormalization. Let me get this copy. Okay. So when is I hope you are close. If you see here, this is a sales table, right? In a denormalized form. So what it mean by denormalized form? Now, if you see, whenever the transaction information is captured, that I am storing a detailed information like product name, customer address, right? And in detail. Now, as a customer, if I come to that same shop multiple times, so that many times my address and everything is captured, right? Similarly, Michael has came and he has purchased two products. His entire information is again captured, right? So a denormalized form is capturing as much as information in the single table. So the benefit of this one is if you want to retrieve the information, you can retrieve the information very quickly, faster, because we need to refer only single table, right? But the problem here is we are storing the data redundantly, right? Which means that we need more disk space. That means more cost to the company. And is it really being worthy? Sometimes it may not be, right? Think of it, if I'm a visitor, regular visitor to a particular shopping mall, right? In a month, I visit 10 times. In a year, it goes to 120. Similarly, if there are 1,000 customers, so for these 1,000 customers, they are repeatedly storing their address, right? So that means we would be putting our money on with where there is no value, right? So storing data, everything in a single table or in a detailed, we call it as denormalized, right? Now, how we can address this issue, avoiding storing duplicate data, right? Then we can normalize this table. That means we can split the table into we can store the same data in multiple tables by logically separating the things, right? Say if you know that a customer address or customer details would be referred multiple times, then I'm going to create a customer address table and I'm going to store a single line for customer address and I'm going to give a unique reference number. We also call it as a key or primary key, right? A primary key is a unique value that helps to identify single record in the table, right? Similarly, like customer address we also create a separate table for the products and we are going to give a unique reference number, right? Now, whenever you want to do some sales, right? Say product one. Now, instead of storing entire details of product, I am going to store the primary key of that product here, right? Similarly, the customer's primary key. So we also call them these as a foreign keys here. So in the sales table, these are acting as a foreign key. That means this foreign key has a unique reference in their respective table, primary key table, right? So the concept of loading the data into multiple tables by logically segregating them is called normalization. And the first benefit we are going to get is the effective utilization of space, avoiding data duplication, right? And these are also going to help us in the analytical processing, right? And if I show you this particular relation in a tabular form, right? Let me open that particular topic. So Power BI has also referring this particular concept. And let me show you one interesting statement here. Yeah. Star schema is a mature modeling approach widely adopted in relational data warehouse. It requires models to classify their data models, right? So why we are using this one? Let me show you the diagram. If you see this diagram, right, that represents the table. Yes, I am having my sales table sitting at the center that is going to capture information related to whatever the sales happened, right? Now, whenever sales happen, that we would be having an employee who do the sales, product that is involved in that sales activity, date when the sales has happened. Now, instead of storing a detailed information about the product or employee, I'm going to store the primary key of this product and employee in the sales table, right? Now, sales table sitting at the center related to the different dimension tables, right? So the center table, we call it as a fact table that is going to store facts, right? A transaction, an observation, and a dimension table support this fact table, right? Like if you see, if you take an object, we ask, hey, what are its dimensions? What is the length? What is the breadth? Similarly, each fact table is going to have dimension tables that are going to store a detailed information about the primary keys that it is going to store. Right? We should be understanding this concept with crystal clear so that whenever you are getting the data from your upstreams, then you can easily correlate this one. Why things are stored in multiple tables, not in one table, and why especially these tables are created, right? And if I see this one, power base image depends upon power core table. That means that must power core it transfer when you represent not this one. This one. Yeah, I just want to show you one. Star schema design and many related concepts introduced in this article are highly relevant to developing Power BI models, are optimized for performance and utility, right? Don't the company end up paying the money for storing multiple tables? Yes, Roland, it end up with multiple tables, but overall space wise, you are not going to take more, right? Company is fine to have more tables because it don't charge based on the tables. Normally, company charges based on the space that we are going to utilize. Okay, they may take some service if they want you to maintain the things, right? Say like you can have multiple connections, but they were going to charge how much data you are going to use like that. Okay, fine with multiple tables. Like you can have multiple connections, but they may charge on how much space or how much data you are going to utilize. Hmm? And even in the current world, it is very difficult to have single table model. Okay. Okay. Now, let us see in detail. A dimension table describes business entities, right? Entities can be products, people, places, and concepts, including time itself. That's what, right? We have seen. If you see, the dimension table is going to store customer related information, product related information. Say, suppose if you want to see total sales by laptops, total sales by electronic goods. So these dimension tables will also used as a filters, right? Say, I want to filter out what are the sales done for the electronics items or hardware items. Then we can use these dimension tables for filtering. Similarly, this fact table would be used for aggregating. What is the total sales? How many products are sold? Quantity, right? Like that, right? The most consistent table you will find in a star schema is a date dimension, a dimension table. Fact table stores observations or events and can be sales, orders, stocks, balance, etc. and more. A fact table contains dimension keys column that relates to dimension table and numeric measure columns, right? If you see this particular example, fact table is going to have the key columns, dimension key columns, and the numeric values for the event that has happened. Correct? To get, for example, and they have given and a detailed description. Right? Normalization is the term used to describe data that's stored in a way that reduces repetition of data. Right? And they have given an example in below. That's the same sample that we have given. They are showing normalization helps repetition. Right? Star schema design and many related concepts introduced in this article are highly relevant in developing Power BI data models that are optimized for performance and usability. Right? In the current world, single table model is not practically feasible. So we should be having multiple tables. Those are in the star schema, right? The design fits well with the star schema principles. See, a well-designed model then is one that provides tables for filtering and grouping the tables for summarization. Dimension tables enable filtering and grouping. Say if you want to group the total sales by a product, by a customer, or by an entity, then dimension tables are going to help us. Similarly, we have a fact table for summarization, right? There is no table model that model set to set table time dimension or fact. In the fact dimension by the model relation, right? And if you see here, as we said in the dimension table, we are going to have one record, right? If you see here, if I want to have a customer ID, and when I refer to the dimension table, I should be finding only one record for this customer ID. That is the reason we call them as a primary key. It's a unique. Okay. If you have more than one table, then it is hard to find out this transaction is related to which customer, right? At the same time, one customer can have multiple records in the fact table because I can go and purchase multiple times, correct? So it's a one to many relation, right? Same thing is provided. A dimension table is going to have one to many relation. See, star means many string. A well-structured model design include tables that are either dimensions or facts. Avoid mixing the two types together for a single table, right? So a detailed things about what is measure, what is surrogate key, and there are different dimensions are there, right? I'm not going to touch base with this one, but if time permits, I would request you to go through all these things. Okay. Similarly, we have snowflake dimensions, right? Say if you have one level of relation, a fact table is connected to a fact table is referring to a dimension table. Then it is a star schema, just how you see the star, right? It is going to have four edges. Now, within the address table, right? When you say address, right, you would be having city and state coming, city, state, country. Now, is it a wise decision for everyone that we repeat city, Texas, state, Texas, and country, United States of America? So in a city, you would be having 1 million population. So all the 1 million population, instead of writing all the three columns, right? I would be creating a city table, which would be having a unique value for each and every city. Now in the address table, I am going to use this unique value. So that means sales table is going to refer customer table for customer address, and customer table is going to refer the city table for the city related details, right? So whenever you are retrieving the data, the process should be reading three tables. So that means the overall response time increase, but we will have the benefit of avoiding data duplication of the data, right? That is called snowflake. So when you have multiple levels, then we call snowflake. Okay. The more snowflakes you have, then the data redundancy would be reduced to maximum extent, right? But how many levels of how many levels we can break it down, that is purely depends upon the appetite that company can maintain. Okay. So if you go for more levels, then there would be confusion also. So keep it short and simple. That's a simple answer, right? So this is about star and snowflake schema, right? So we have covered the topics related to the basics of data warehousing, OLTP and OLAP, and two great scientists, the theories proposed by the two great scientists, Inmon and the Kimball, data warehousing and data star and schema. And the important thing is data normalization and denormalization, right? These topics are like correlated to each other. Sorry, guys. Now, let me take some water. Sorry. Yeah, I'm back. Yeah, I'm okay. It's just uh, I'm going to send you this class recording, right? Along with the topics, let me show you how the mail comes. Vanessa, especially for you, right? Daily, you are going to get two mails, right? One is about the class summary. This is generated by the artificial intelligence Zoom AI companion, right? This will gives you a glimpse of what are the topics we covered and what things that you should do after the class. I would request you, please don't miss this one. Go through this meeting MOM, and this would be coming as class number and meeting summary, right? And another mail you are going to have class number, subject line with the topics we covered and our batch. And this is going to have class recording and the knowledge article that you should be reading and thoroughly. And I would be giving you the project related task, right? These are like task in a project, how we give, or you can say project tasks that you should be completing them. Okay. So it's like, okay, we got the training and now we should be completing the task that are given to us. Okay. So that will helps us to me to understand what is the level of knowledge you gain and what to be done to further enhance it, right? So let me stop the class for today.